Firstly, a word in favour of ice. Try working in Korea and China where they haven't had any and compacted all the stuff, and you end up, it's like custard with a thin skin on it. I'd much rather have the ice. Okay, that was a little aside. Fast feeder vessels. This is one, we're talking about cost reductions this afternoon. We've seen at DNV, and we're doing a research project. This is kind of an update, a sort of a phase one end update for you on some of the first early findings that we're finding on potential savings associated with using a different technique for installation, a logistical model and a slightly different vessel type. Okay, so let's just look. In terms of costs, the vast majority of costs are associated with the charter costs of the main installation vessel. So you want to reduce the time that that vessel is actually on site. I've said here, cost, time is money. So let's look at the installation cycle itself. Most times we assume that the installation vessel is going to carry the components to the site and act as its own installation vessel. We'll come back to that. So let's look at the elements of an installation cycle, a standard cycle. I'm sure you'll recognise these. We load up in port, we transit to the wind farm, we install the components on the wind farm, and we go back again and we reload. Nothing too complicated there. So, as I've said before, if you'll excuse me, if we had a 25-hour day, and there were 4,000 seconds in an hour rather than 3,600, I appreciate. Just roughly, though, but for every £100,000 a day, or 100,000 euros it says there, you're looking at €1 or pound a second that these installation vessels cost. So if you can save time, there is very, very considerable savings to be made. Save an hour, you've saved £4,000. Save a day, you've saved $100,000. So the costs and trying to shave tiny little parts off the cycle time is vital. Okay, as you move further offshore, well, the loading import time doesn't change much, and neither does the installation time for the component. There are changes, I appreciate, but let's just stick with the easy bit at the minute. But if we look here, what really changes is the durations of the voyages offshore and return. So what vessel specifications could you use to reduce the additional voyage costs as we go further offshore? Well, you can have a faster vessel. That will reduce the voyage time. Or you can have a greater capacity on your vessel, and then you're spreading the costs over more units. So if you've got 3 on there, you get a certain rate. But if you can actually carry 6, you've halved the unit costs of all the voyage times. So that's what we've seen, isn't it? Larger and larger wind turbine installation vessels to cater for these long transit durations. Okay, let's just have a quick look at the fast feeder vessel. Now, a fast feeder vessel, I'll explain a little more what I mean by that. Let's just challenge that assumption. The main installation vessel transports the components to the offshore wind farm. What if components are delivered? Now, a fast feeder vessel, the suggestion is the components will be taken to the wind farm and delivered offshore onto the deck of the installation vessel itself while it continues to install. That's what we're talking about. That's where the real savings come. And let's look at what those savings would be. We're just talking hypothetically at the minute. Right, well, we're now looking at the installation. This is the installation vessel cycle now. If it's being fed, well, none of the voyage costs are part of the installation cycle. They've been transferred to another vessel. So we've saved all of those from the actual installation vessel's cycle. We're making our installation vessel work harder. And that, obviously, the further offshore you go, the more those savings will be. If now we are delivering onto the deck of the of the installation vessel offshore, doing a vessel-to-vessel transfer offshore, you're then saving the time that you took to load the vessel in port. But you are increasing. You have all of the costs associated with the fast feeder vessel. This is not going to be a cheap vessel, but what are the overall costs? First question to ask, and I think this is where it's fallen foul. People have been saying, oh, vessel-to-vessel transfers offshore, horrible, don't do that. If there's any marine warranty surveyors in here, I'm sure that's exactly their instant reaction. Well aware of the complexities of it, but I believe it's lived in the too difficult box, as I call it, and I think the too difficult box is my inbox, judging by my inbox and what it looks like. I've fished it back out of that box. No, we need to engineer solutions here. The savings are too vast that we can just bury our head in the sands and ostrich engineer over it. We need to actually resolve what are the things that are needed to do offshore vessel-to-vessel transfers. And it is, I think everybody would say, it's technically possible, but extremely challenging marine operations. But we need to do that. And then the question becomes, on balance, which is the cheaper? Is it the conventional methodology, or doing it via a new novel technology, properly engineered? I appreciate the challenges. That's why it's not been done. It's a no-brainer when you do the sums, but at the end of the day, it's the complexities of actually addressing yourself to solving the problems that really are the technical challenge. Okay. So one of the things that's key, we've already talked earlier on about quite a lot about the how Siemens have relocated. Well, this, at the moment, the dream scenario, if you're on a wind farm, is you look to shore, and there on the shoreline, as close as it can get, is your turbine manufacturer. And then right next to them is your foundation manufacturer. That's about as close as it can get. So then you find that your wind turbine installation vessel, your installation vessels, just have to cycle into shore and out from shore. That's the dream scenario. The grief is that in the real life, we know that the foundation manufacturer is miles away, and the turbine manufacturer is miles away in a different direction. And you have these huge distances now. For that very expensive vessel, £1 a second, £2 a second, £5 a second, some of the things we're using, for it to transit these huge distances is just uneconomic. So what we've been doing is we've been having marshalling ports. We've been taking all of the components via the best form of long-distance transfer, cargo vessels, to the nearest port on the shore adjacent to the wind farm and working our wind turbine installation vessel hard. What happens when you get fast feeder vessels? Well, suddenly you find that you can now keep your wind turbine installation vessel on the wind farm and go direct from manufacturer to wind farm. I've shown this at ports conferences, and they don't like the next bit of this slide. When all of the revenues associated with marshalling ports have disappeared, but probably in case there's any ports people here, we'll move on quickly. Don't depress anybody, we've had plenty of that this afternoon. But the long and the short of it is that I've used this word development density. How many gigawatts are going to be developed within a certain radius of a certain port in a certain time? When there's a high development density, you see that manufacturers know they've got a competitive advantage if they move there and developers can cycle in and out of their port. So they relocate and just simply, basically, where there's a high development area, the manufacturers relocate to the port. Okay, so fast feeder vessel technology. There's an intermediate step here where we're talking about the logistics, the handling of these huge components. There's a big leap here where we've moved forward and we've suggested the natural evolution of heavy component logistics. Back in the past, if you have one component, it's sensible to do welded sea lashings. That's, it's a low level of optimization, a low level of standardization. Slightly more standardized, whoops, gone one too far. Slightly more standardized, but not very well optimized, is the pad-eye and shackle, for those of you who are rusty and salty, for those of you who forget it. Roll and roll off. If you go on a ferry, you'll find that there are rows laid out for lorries and cars. So you're slightly more standardized, and there you can afford to use more standardized, more optimized lashing solutions. This is called the clover leaf, and that's called an elephant's foot, but you don't need to know that either. But the most standardized and optimized solution for logistics is, of course, the ISO container. Very, very swift, absolutely standard sizes, twist locked, turn that 90 degrees, it's locked solid and sea lashed. In our industry, I don't think we're ever going to get there. Well, we will see. But project cargo unitization, making many big lumps of cargo into one unit. The best we're seeing at the minute is with blades, where we are seeing blades put into racks. Sometimes they're lifted in groups of 3. Sometimes I've seen various drawings where there've been like a whole rack to be lifted on as a single unit. The logical extension of this is what I'm calling whole turbine unitization. Now, what do I mean by that? Well, a picture tells 1,000 words. This is putting a complete turbine onto a single transport frame. So this frame can be rolled with SPMT's self-propelled modular transport units, the multi-wheel trailers. It can be set down. It's got twist locks underneath the bottom of it, so it can be literally lashed onto the deck with a single twist lock like a container. I'm not belittling the logistics or engineering associated with that. Again, each one of these is an adapter plate, and that could be adapted to fit any turbine. So a novel logistic strategy is the wind turbine cassette, ro-ro handling system. It could be used onshore around the ports, but also offshore. If you have a jack-up feeder vessel and a jack-up wind turbine installation vessel, you literally have two platforms and you can roll between them. Not belittling it. Any marine warranty surveyors here? We will engineer it. We are capable of such things. Anyway, so there's a lot of rapid sea lashings. Once the cassette can deduct any turbine, once the turbine installation vessel has been immobilized once to fit the cassette, then you can use it for anything. We're also talking about using it for foundations as well. And that's the sort of, just to give you an idea of scale, these are sketches. Don't believe me, I don't think these are exactly solutions. These are just concept sketches just to illustrate the points. But that's the sort of size it would look like on a standard, anybody who knows C2000s, 2 minutes, very good, no problem. Okay, so what we're saying here is that once the turbines are mobilized, they will take any turbine type. We can use smaller wind turbine installation vessels. If you remember, we are only using large vessels to cut the unit transit costs. We're not transiting. We don't need to do that anymore. So I'll move on quickly. So we have done some cost-benefit analysis using, this is an in-house developed piece of software, which I think is actually going to be sold on the market. We're developing it for actual sale in the near future. We define what all of the elements of the cycle times are, what their Met limits are. We get all of the Met ocean data, and we do some time domain analysis. And this is what we're trying to do. We're trying to find out what the cost of the overall alternatives are, fast feeder vessel versus conventional installation strategies. And we have done that. We're talking about client here. This is a slide presented obviously for commercial things, but we were the R&D project was the internal customer here. So you end up with a kind of a probability curve like this. This is your P50 likely duration or cost, and then you can work out P10s and P90s. This is just standard analysis of how the sort of risks of durations associated with projects. Now this is the R&D project ourselves, our fast feeder R&D project. We said, well, unless we can find 25% savings, it's not worth doing it. So I said before there was a distance between the manufacturing port and the marshalling port, and the marshalling port and the offshore. This is the manufacturing to marshalling port distance, and these numbers here represent how far offshore from the marshalling port the wind farm is. The bottom line there shows the fast feeder costs, and these others are showing what the costs are with other types of vessel in the same sorts of scenarios. And these are actual costs. We've modelled a number of different scenarios at the minute. We're at early doors yet. And the gist of it is we are trying to come up with what is the optimum size. This is, again, just a concept sketch. Please don't think that I'm necessarily going for catamarans. I just thought it was prettier to show it at here. But again, it doesn't have to be a jack-up feeder vessel, but trying to carry out heavy compensated, heavy lifts of anything up to 1,500 tons offshore, vessel to vessel, in close proximity. If I had any hair, I'd tear it out. So this concept shows you that this has actually got 1, 2, 3, 4, 5, 6 positions. And this vessel, this wind turbine installation vessel is a mid-range size, a standard wind turbine installation jack-up. That could feed several, we've done it now with modelling with several of the 2 capacity wind turbine installation vessels and 1 feeder vessel. And as I say, depending on the conditions, how far you are offshore, etc., you find that there are different savings, but this is definitely a method where the overall installation costs, the overall project time is greatly reduced, but the amount of time that wind turbine vessels are doing wind turbine installation or foundation installation is greatly increased. They're more efficiently used by this method, and it's definitely showing potential as being as a cost saving. I talked a while back under the subject of there's a vessel missing from my offshore wind farm dream team. Well, we've identified the new team member of my dream team. It's a fast feeder vessel. There definitely are savings to be made, and hopefully at some time in the future, as this research and development project carries on, then hopefully we'll have some more news for you. We would actively be keen to talk to others who might be interested in partnering with us on moving this forward. We are talking with some clients on it, but we will obviously be very keen to talk with others. Okay, I hope you've enjoyed seeing this concept. Thank you.
Thank you very much.